Hi guys, so this is your class for Elgamal Cryptography system. So this is basically your PPT. So as far as we have seen in all the other cryptography algorithms, we have three things to find out. So that is key generation, one is key encryption, and another is the decryption, key decryption. So here also the same things exist. This is a simplified Diffie-Hellman key exchange algorithm. This is it, and next we need to find out the key generation technique. This is the key generation technique. Select a large prime number, which is P. This is the first part of the public key. Then we have step 2, which is select a decryption key or private key D. Then we have step 3, select the second part of public key as E1. The third part of public key as E2 is equals to E1 to the power D mod P. The public key will be E1, E2, P, and the private key will be D. So here there is one example shown over here. We will do it together, okay? So you don't need to worry. Then we have key encryption. Same, we have some specific algorithm, and we have certain things that you need to remember. These are the two things. C1 is equals to ciphertext 1 is equals to E1 to the power R mod P. Ciphertext 2 is equals to PT into E2 to the power R mod P. The final ciphertext is C1 and C2. Then we have decryption, which is PT, which is plain text, is equals to C2, which is ciphertext 2 into ciphertext 1 to the power D to the power -1 mod P. So this is the decryption technique. Let's just do it together with one example. We'll do this example only, but we'll solve it out, okay? So this is okay, say in the example they said we have a prime number. First we have to consider a prime number, large prime number, right? So say there that is P is equals to 11. Just a second. Okay, so we were supposed to see the example. Let's do one example that is shown already shown in the PPT, but let's just do it together, then it will be more understandable to you guys. So say in the example it says that with the prime number that you need to select in the step 1, that is, say let's consider it as P is equals to 11. Okay, and they are also saying to consider D is equals to 3. Okay, so the algorithm says select a second part of the encryption or the public key, which is E1. That also you need to consider as is equals to 2. Okay, so the third part of the encryption key or the public key, which is E2. Okay, this is the step 4, I think. E2 is equals to E1 to the power P mod P. Now this you need to calculate, we need to calculate. So E2 is so we have P, right? We have P, which is say which is P is equals to 11. We already have P is equals to 11. We have E1 is equals to 2, right? So we have all these things. We have D is equals to 3 as well. We have written all those things. So it says, so 2 to the power 3 mod 11, right? So 2 to the power 3 mod 11 is 8 mod 11, which is 8. So this is your E2 ka value. Now your public key in the algorithm, as it says, it is E1 comma E2 comma P, which is equals to 2 comma 8 comma 11. So this is your first step of your algorithm, which is key generation, right? And the and your private key, which is D, is equals to 3. Okay, so D is equals to 3. These are the two things that we have already found out, which is key generation. Right, now the next thing that you need to do, just a second. Yeah, so the next thing that you need to find out is the encryption process, correct? So in the encryption process it says we need to find out two ciphertext, right? So C1 and C2. So C1 and C2. So C1 ka formula is E1 to the power R mod P, correct? Yeah, I mean E1 to the power R mod P, correct? So this is the ciphertext 1. Then we have ciphertext 2, which is PT into E2 R mod P, Let's just confirm it once again in the PPT that we have over here. Okay, so we have the ciphertext. This is the key generation technique, right? Now we have encryption. C1 is equals to E1 to the power R mod P. C2 is equals to PT into E2 to the power R mod P. We are doing it correct. So let's just go back to the slide again. So what you need to find out over here is we need to calculate the whole thing, right? So ciphertext 1 is equals to E1 to the power R mod P. Now let's say, as for the example we are going on, let's say R is equals to 4 and say plain text is equals to 7. Okay, so the C1 by the formula it says 2 to the power R, which is 2 to the power 4 mod 11, which is in return 16 mod 11, which is further 5. So C1 is 5. C2 is plain text into E2 to the power R mod P, which is 7. We have taken plain text as 7 into 8. Okay, 8 to the power 4 mod 11. Okay, now this is okay, what is the value then? It will be a very big value. The one that we have calculated, I mean I have calculated, it is 28672 mod 11, which is further equals to 7. Okay, you can check it in your calculator as well. So C1 and C2 ka value is over here. Okay, so plain text into E2 to the power R mod P, that's what we have constituted and substituted the values and found out E2 is equals to 6, C2 is equals to 6. Okay, so the next thing that we need to find out is, so we are done with C2 and C1. C1 ka value we got as 5, C2 ka value we got as 6, right? So the ciphertext that we have in together is 5 comma 6, correct? Now we need to find out the plain text, right? I mean the decryption process. The encryption is done already. The encryption is here in front of us. Now we need to find out the decryption process, which is a little bit tricky since we have inverse algorithm, inverse technique over here. So as far as the formula says, it says C2 into C1 to the power D mine inverse. Okay, inverse, let me just put it in bracket, then it will be much more easier to you guys. D ka inverse, then we have mod P. Okay, so this we can substitute as the value, like say C2 ka value we have as 6, then we have C1 ka value as 5. So C6 into 5 to the power 3, D ka value is already we have taken, considered is, okay, I mean in the previous slide you can go and check. So we have considered that value as well. So 5 to the power 3, which is minus I mean the inverse one, this also you can put in a bracket. So 5 to the power 3, then inverse mod ka P, which is P is 11. At the beginning mein we have found out this, not found out actually, we have considered this value as supposingly. So mod 11, and so we get the value as so you need to find out this value first. Okay, you need to find out this value. We'll just go to the next slide and find out this value first. Yeah, so 5 to the power 3 is what, 125, right? So the equation says 5 to the power 3, then iska inverse, inverse mod 11, right? We need to find out this. So 5 to the power 3 is 125, right? 125 mod 11. So 125 if inverse mod 11, this is the equation, right? So as for the inverse formula that we know, you need to find out 125 into x, okay, mod 11, which will give you 1. So this is the whole equation that you need to find out. So I have calculated that value, and it says the x ka value is 3. Okay, x ka value is 3. So actually the thing is 375 mod 11, which in return gives you 1. Okay, so this is the scenario. Now going back to the previous slide over here, 5 to the power 3 inverse mod 11. So here we get x ka value is 3, right? So 6 into 3 mod 11, okay, which is in return 18 mod 11, so which is 7. Okay, so your plain text is 7. Going back to the previous slides, yeah, over here, so basically we have found out now, as per the example that they have solved over here. Why I did it with you guys, that's a thing, because you won't be able to understand how they have computed the values. So we also did it in the same way. Okay, so consider p is equals to 11, e1 equals to 2, d is equals to 3, then e2 is equals to e1 to the power d mod p, which is 2 to the power 3 mod 11 is equals to 8. We also did that same thing. Hence public key will be 2 comma 8 comma 11, and the private key is d is equals to 3. We have done that thing, right? So this is the encryption part that we did. R is equals to 4. I have already told you guys, and PT is equals to 7. We have considered this thing. Now from the previous, P is equals to 11, E1 is equals to T, D is equals to 10, public key will be 2 comma 8 comma 11. So we have just substituted the values over here. E1 to the power R mod P, 2 to the power 4 mod 11 we found out. So that is 16 mod 11, which is in return 5. Then we have C2 is equals to PT into E2 to the power R mod P, which is 7 into 2 to the power 8, 2 to the power 8 mod 11. So it is 7 into 8 to the power 4 mod 11, which is equals to 28672 mod 11, which is 6. Here the value is missing. Okay, then we have the ciphertext is equals to 5 comma 6. This is the whole thing for encryption. Now we have decryption ka part over here. PT is equals to C2 into C1 to the power D to the power minus inverse, inverse, and mod P, right? So here they have just substituted the value. So 6 into 5 to the power 3 inverse mod 11. Okay, they have just put on the values over here, but I've explained you how you need to find out. So 6 into 3 mod 11, which is 18 mod 11, which is equals to 7. So this is the whole scenario of Elgamal cryptography. There is nothing, I mean, hard and fast. We have already done many such hard and fast algorithms. This is nothing like that. Okay, so that's it. Okay, bye.